Hello, hello, hello. And thank you for coming back to Crypto Delicious and my Bitcoin Musings series. This one is Bitcoin Musings number 3. We're going to try and answer the question, how do Bitcoin keys and addresses work? Where do they come from? That's another question. That's probably the main question, actually. Where does this Bitcoin address that you see when someone shows you a Bitcoin address, where did that address come from? How was that created? So we're going to get into that. And this video, I'm going to try and keep it a little shorter. The first two videos were a bit on the long side. So we're going to kind of move along maybe a bit more quickly. And hopefully this won't drag on and it won't feel like it's too long. Okay, so birth of an address. A Bitcoin address is created by the following process. A random value becomes a private key. Okay, it all starts with the private key, and the private key is just a random number, a large random number. So I've got that word random in bold because that's really important, and it's something that is sort of fundamental to understanding how this works, because a lot of times when we think about getting an address to something or getting an account number, many people, they liken the Bitcoin address to an account number. Okay, and when you think of an account number, you think about going to the bank, opening up a new bank account, and you go to your local bank branch, and the helpful person behind the counter helps you create or helps you open a new bank account, and they tell you what the account number is. And that's the way we're used to. We live in a centralized world. We go to places, we start a business relationship with someone, or we register somewhere, and they tell us what the number is. This is completely different. Bitcoin is decentralized. So we create our own number. We don't do it just willy-nilly by ourselves. We have something that a very formal process in which a random value becomes a private key. Okay, so that's very important. A private key is just based on a large random number. And then once we have this Bitcoin private key, then we can in turn convert the private key to a public key. Okay, and then once we have that public key, we can convert a public key into a Bitcoin address. And we're going to demonstrate that in a few moments. But fundamental here, it all starts with a large random number. If you only take away that from this video, that's important. It all starts with a random number. So again, Bitcoin is not issued by a central authority. Okay, the address is created offline, away from the blockchain. It's completely independent. And this is sometimes hard for someone just coming to the space to get their head around, because we think about everything being centralized. And it's not just that. Like, maybe, okay, you're saying, okay, I got this random number. I understand that. I can generate my own random number. How does that number get onto the blockchain? Like, how does the blockchain know about this new number? And the simple answer to that is it doesn't. This new Bitcoin address, it doesn't exist on the blockchain until after a transaction occurs. When that transaction occurs with this address, it will be processed by a Bitcoin miner and it will be added to the blockchain. But up until then, it doesn't exist. It only exists on your device. So, okay, we're going to see that a little later. Just a quick note here about random number generation, okay? You can't just create your own random number just by writing down these numbers, 160 whatever numbers. It's obviously larger than that, but you can't just write it down. It has to be a very formal random process. So Bitcoin uses a strict definition of what's random. So whatever programming language is being used, it follows very defined rules, and the random number is something that is safely random. Sometimes this is getting a little technical, but it's important to understand a little bit, even if you don't completely understand it. It's just to kind of be introduced to this concept, is that a random number can be generated lots of ways, but it could be that it's not a safe way. It could be that the random number is somewhat predictable. And if a random number is somewhat predictable, it's not safe. Okay, so a full explanation is beyond the scope of this video, but it's important because a Bitcoin private key is just a randomly generated number. If that randomly generated number is generated in a predictable way, then it is vulnerable to attack. So, okay, we've got that. Private key produces a public key. Okay, so I mentioned that at the beginning. So again, this is a very formal process. There's functions that are already defined to do this for us. We just have to execute them, and we convert the private key into a public key. Now, when we say public key, a public key is not the same thing as a Bitcoin address. That's important. A lot of times we don't think or we don't have to look at this stuff, right? We just have our Bitcoin address and we just use it. But underneath that, there's a public key, and underneath the public key is a private key. Okay, so there's a crypto function that's applied to the public key, and then that will in turn become the Bitcoin address. I've got an example here of a private key. This is a private key, 5K, blah, 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 blah. Don't worry, there's nothing in there. Just you can try and use that if you want to. I don't think you're going to get anything. But the public key would look like this. It's longer, and we see that it's that would be a huge number if it was converted into decimal. You don't have to understand all this hexadecimal, decimal, binary. I'm just trying to demonstrate here that there's a difference between a private key, a public key, and a Bitcoin address. Okay, and the steps involved. So once you have this private key and then you have the public key based on the private key, then the next step is to get this Bitcoin address. And just so you're familiar a little bit with this, you've probably seen one of these before already, but it's confusing for new people sometimes because they'll see a Bitcoin address and sometimes it starts with 1, sometimes it starts with 3, and other times it starts with BC1. Okay, so this BC1, that's sort of a more modern way of generating a Bitcoin address, and it's sort of the preferred way. But I'm just introducing it here just to show you these are the examples of what a Bitcoin address looks like. Okay, so by applying a crypto mathematical function to a public key, we get a Bitcoin address, which could look like one of these 3 examples. Okay, so going back a step here to the beginning, we can take a moment to think about this and say, okay, hey, if I know a private key, then I know the public key, and if I know the public key, then I know the public Bitcoin address, the Bitcoin address that I give to everybody. So if someone gives me their Bitcoin address, maybe I can just reverse engineer everything, and then I have their private key, and then I can just take whatever they have. No, not quite. It only goes one way. So you cannot reverse engineer. And to fully understand that, you would probably have to be a mathematician, but suffice it to say that it is based on very complex math, which you cannot reverse. It's fundamentally the fundamental mathematical principle there that you cannot reverse engineer. It's called elliptic curve geometry or something like that. You can Google that and you'll find lots of information. Okay, but just going through here, if you know the private key, you can generate the public key. As I said, you cannot do the reverse. And again, the private key is the key to everything, so it has to be kept safe, right? If you have a private key, you cannot let anyone know what that private key is. If anyone knows what that private key is, they can unlock your funds and take your funds whenever they want. But the point of all of this that I have here on this page is when we think about it, okay, if this private key is a random number, what if I just generated millions and millions of random numbers, and eventually I'm going to generate a private key that already belongs to someone else, right? So I could just create a whole bunch of them, and then I could eventually find a private key that belongs to a Bitcoin address that's already out there. And then I could just take their funds, right? Well, actually, no. It's basically impossible. That would be really bad if that was the case. But in order to understand why this is not possible, we have to think about the vastness of the universe. and Bitcoin. So the universe obviously is huge. Like it's really beyond our comprehension. There's billions and billions of galaxies. Each galaxy has billions of stars. I mean, these numbers are just so huge, we can't really get our minds around it. But just to get sort of the concept here, just think in smaller terms for a moment. If you picked a random number between 1 and 10, what are the chances that you're going to pick a number that already belongs to someone else? It's pretty high, right? There's only 10 possibilities. So if there's 10 people that each have a number, a unique number, and you pick a random number, you have a 1 in 10 chance of picking a number that someone else has. But what if we say 1 in a million? Well, that's a lot harder. You know, if you just have 10 people that pick a number between 1 and a million, what's the chance that you're going to pick a number that they have that belongs to them? Much, much smaller, right? Okay, now let's move it up a notch to a trillion. Well, if you pick a number between 1 and a trillion, and so do 10 other people, what are the chances that you're going to pick a number that they have, which they've chosen between a 1 and a trillion? Not very likely. Okay, now, so when we think about a Bitcoin private key is a 160-bit number. So when we talk about computers, we talk about bits. A bit is just a binary digit. It's a 1 or a 0. So how many possible different numbers can there be for a private key? The short answer is 2 to the power of 160. Now, that is a lot bigger than a trillion. That's actually, I don't even know how you would pronounce that word for how big that number is. But you could think of it this way. If you calculate that, that number is actually more than the number of atoms in the universe. That's how many possibilities there are for a Bitcoin private key. So to try and explain it another way, even if you could generate 20 billion addresses, okay, even if you could generate 20 billion private keys a second, it would take you trillions and 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 trillions, trillions, and actually more trillions, and actually a lot more than that, trillions of years to before you came to a number that possibly already existed that belonged to someone else. Okay, that's how impossible it is. I mean, theoretically, there's always going to be people that say, "Oh, theoretically, it's possible. You know, it could happen." It's not really, and you could get, again, this all comes back to very complex mathematics and having a PhD in math to really try and prove that this is impossible. But let's just suffice it to say that it's practically impossible. Okay, so just for fun, we're going to try and demonstrate this using a programming language called Python. And if you don't know programming, that's fine. You don't have to. I'm going to show you a quick program here. So we have Visual Studio Code with a Python program. And in this Python program, you can see I've got my private key here is a random key. My public key is based on that private key. It goes into this function, which converts a private key to a public key. Then I have this public key. I take this public key and I put it into another function, which converts a public key to a Bitcoin address. And I display these three things. Okay, so I'm going to show my terminal here where I have the terminal open to the location where I have this script, and I'm going to execute this script here that I have, gen btc keys. So voila, everything I've been talking about is right here. We have a Bitcoin private key, that's this. The public key that is created based on that private key is this huge long number. And then the Bitcoin address, which is based on the public key, is here. And notice it starts with a 1. So this is a Bitcoin address. I just created it on my Windows computer. It doesn't exist anywhere else, but it is a valid Bitcoin address. If I wanted to conduct a transaction. If I wanted to send some funds to this Bitcoin address, I could. I'm not going to, because I've just shown you what the private key is. So that would be quite foolish. But theoretically, this is how it works. And it's completely random. Okay, if I execute this program again, in fact, I will do that right now. So I'm going to execute this program again. Completely different random number. Bitcoin private key here, public key based on that private key, Bitcoin address. And I could do it again, and I could do it again. I could do it as many times as I want to. Okay, so imagine I did that 20 billion times. Each one of those numbers would be unique. It's hard to believe, but you can do it yourself if you like. I'm actually, okay, so let me show you here. I've got this little program here to generate keys. So just for a second here, I can show you I've got this program, generate keys. It's going to just create 1,000 of them. But if you have a good computer and lots of disk space and you want to create 20 billion of them, go for it. And you will see that they are all unique. Okay, so I'm going to actually execute this right now. Okay, so let me show that to you. I'm going to execute this gen many keys, and it's generating, it's working. It takes a little time because, I mean, it's doing a lot of mathematics, but it finished. So you can see it takes a few seconds to do 1,000. So imagine if you do 20 billion, you're going to be sitting there for a while. You basically have to go away and come back. But you could do it. But for the purpose of this, I'm just generating 1,000. So here, if I do a directory listing, you can see that this file here, random keys with this timestamp, was just created just a moment ago. Okay, so we've got this file here. I just created it. Let me get rid of the terminal here so you can see this better. Okay, so you can see I've got this freshly created file. There's 1,000 addresses here. Okay, this is a Bitcoin address, and in the program you can see that the way it's, you got the public address here, you got the private key and the public key. Okay, so the idea here is if I have this address, I have the private key right here that goes with it. So I could unlock this if anyone else has sent anything to this address. Okay, and I've got 1,000 of them. Thing is, none of them exist for the reasons that I said before. It's just the numbers are astronomical. The chance of it happening makes it impossible. But I've got this program here to check the keys. So the idea here is I can check for existing keys by calling this function here, getAddressOverview, which is from a library here called BlockCipher. Now, BlockCipher will actually go out to the blockchain and check to see if this Bitcoin address exists. Okay, it's expecting a file called random keys. So I'm going to get rid of the old random keys file I had here before, and I'm going to rename this so that it matches what it should. So it's just called random keys. Okay, and I'm going to now run this program. So let me get rid of, well, actually here, yeah, you can see this. So I've got my terminal here. I've got a program which is going to check the keys that were generated in my file. So I'm going to execute that now. And as it's working, you're going to see that it's going to be looking, right? Checking for keys that already exist, okay? Oh, the first thing it did was look for duplicates too, by the way. I'll show you that later after this is done. But right now, this is actually using the BlockCipher library to go out to the blockchain and see if these addresses exist. And they don't. There's nothing to see here. Nada. You know, all of these addresses, they don't exist. The BlockCipher API is checking and it's returning an answer, and it's confirming that these values don't exist. Now, eventually you're going to hit the limit of the API, and you're going to get an error message that says, sorry, you're using this too much and you don't actually pay us to do this, so we're not going to let you do it anymore. So that's fine. I'm going to interrupt the program. Ignore all this. That's just because I did Control C. Okay, but going back to the program, let me get rid of the terminal here. Going back to the program, if we look at this check many keys, I had this function here, check for duplicate keys, and you can see it did this. It opens the file and it went through all 1,000 of them to see if any of them already existed just within that file. So that's how I know for sure that each one of these that I generated is unique. Now, just to prove that the program is working, if I copy and paste a line here, see, now I have inserted a duplicate value. So now let's bring the terminal back, and I'm going to show this to you just so that you know my program does work. It's right, check many keys right here. Okay, I did Control C, so just ignore all that garbage there. But see, I ran it, check for duplicate keys, error, address exists twice, right? That's the one that I copied and pasted, right? We failed, duplicate found, should not happen, sadness. Okay, it only happened because I made it happen. But if I had not have edited this file would have been a pure randomly generated file. Like all the values in it would have been randomly generated. Okay, so anyway, that was just a quick demo. I'm going to put all this up on GitHub so anyone can clone this. I mean, this is very basic Python stuff, but it's fundamental to understanding how a Bitcoin private key is generated, how that becomes a public key, and how the Bitcoin address is based on the public key. Okay, I hope you found it interesting. Hopefully it makes sense. And it's a little technical perhaps, but it's really fundamental. If you're going to get involved in Bitcoin, or you're going to trust Bitcoin and actually put some value into it, like you're actually going to, some of your hard-earned money, you're going to try and invest in Bitcoin, this is critical, right? You have to have confidence in it that it's actually something that is sound, that it's not just a scam, right? Okay, thanks for watching up to this point. I have a feeling this still became a little bit longer than I wanted it to. I really got to work on that. But thanks for paying attention. We've got a quick summary here. Bitcoin private keys are generated offline. There's no central authority, no central issuer. A private key is the key to everything. You have to keep it safe. If someone has the private key, they can generate the @Bitcoin address and they can take everything, right? You have to keep the private key safe. And it's impossible to generate a duplicate private key. For all practical purposes, it's impossible. Okay, so thanks again. Please follow me at Crypto Delicious. That's the GitHub repository there, Crypto Delicious BTC keys. Feel free to clone, use as you like. There's not much there, but you might find it interesting. And please continue on your journey of Bitcoin knowledge and education. I hope this has contributed to that and that you found it interesting. Thanks for your time. Please look out for more videos to come. Bye-bye.